operations, systems of equations, also known as how to use your calculator to do everything for you. Probably have to break this into 2 videos. Let's see how this goes. So some vocabulary here. An m by n matrix has m rows and n columns. So this matrix has 3 rows and 3 columns. And we call it a square matrix because they match. So it's a 3 by 3 matrix. This one has 2 rows and 3 columns, so we call it a 2 by 3 matrix. And then the little subscripts here to show you which element you have in the matrix. So A subscript 2, 1 is in the second row, first column. A subscript 2, 3 is in the second row, third column. It's a lot like working with an Excel spreadsheet. And we can use these matrices to solve systems of equations without having to write out nearly so many steps. And then we'll also be able to put this into our calculator and use our calculator to do the steps for us automatically, which is really cool and a great time saver. Okay, so row operations are what we do and what the calculator does when it does it for us. So the rules are we can swap 2 rows, which is the same thing as writing equation 1 and put where equation 2 is, and equation 2 where equation 1 is. So it doesn't really change anything. We cannot interchange columns. We can only interchange rows. And then the notation I like to use is row 1 is swapped with row 2 here. We can multiply all elements of a row by a constant. So we can take like 2 times row 2, and that's our new row 2. We can replace a row in the matrix with the sum of that row and a multiple of another row. We use this one a lot. So you might say take -2 times row 1, add it to row 3, and make that the new row 3. And let's look at some examples to help you with this. Okay, so starting with this system, when I rewrite this system of equations as an augmented matrix, what I'm doing is just writing down the coefficients. And it's important to keep everything in order. So I don't have an x term for this first equation, so I need to put a 0 in for the x term. Just like when we were doing synthetic division, we had to put in some zeros as placeholders. So this column here will contain all my x coefficients, this column my y's, my z's, and the constant that the equation is equal to. So this is an augmented matrix, and it has 3 rows and 4 columns, so we say it's a 3 by 4 matrix. To start solving, we're going to swap row 1 and row 3. That way we get that leading coefficient of 1. That'll be important to us. And we also have a 0 down here. That will also be important to us. Now I'm going to take -3 times row 1 and add it to row 2. And this will be our new row 2. So we're just temporarily multiplying row 1 by -3. That'll give us -3, -6, +3, +9. Add it to row 2. And this is going to replace my row 2 and be my new row 2. So I've got a 1 here and zeros below it. And what we're going for is something called row echelon form. So the idea is to end up with the first non-zero number in any row is a 1. The column containing the first non-zero number in any row to the left of the column containing the first number row of any row below it. That made a lot of sense, didn't it? Basically, we're trying to get 1s down the diagonal as much as we can, and zeros below those 1s. And then any row that's entirely zeros is at the bottom of the matrix. Once we get into this format, we'll have something where we can back substitute our way back into finding the solutions to all the variables in this system. Let's go back to our example here. Okay, so this is where we were. Now I want the first non-zero number I hit in each row to be a 1. So what I'm going to do is take row 2 and multiply it by -1/2. So divide it by 2 and change the signs. That gives me this new row 2. Haven't changed row 3 or row 1. What I'm going to do next is I want to get zeros below this 1. So I'll temporarily multiply row 2 by -3, add it to row 3. That will eliminate this 3, and it'll be my new row 3. Too many 3's in that sentence. Sorry. So -3 times row 2, row 3, add them together, and this will be my new row 3. Now I want the first non-zero number I hit to be a 1, so I'm basically going to divide this row by 11 and hit it with a negative. Formally, I'm taking -1/11 times row 3, and that gets me to here. So this is now in row echelon form. The first number I hit in each row is a 1, and then each one above is to the left of the one we have, and we have zeros preceding it. Okay, so what do we actually know at this point? We know z equals -2. we also know, I should probably start at the beginning here, 1x plus 2y subtract z is negative 3, y plus 2z is negative 7, and z equals negative 2. So because I know z equals negative 2, I can take that, put it in the second equation, and then coming over here, I can solve for y. So now I know what y is equal to. So I can put y into the first equation and z also into the first equation. And from there, I can figure out that x is 1. So my solution is the ordered triple 1, negative 3, negative 2. And I've solved the system. So this saves us a lot of writing. General procedure. Try to get a 1 there in the first row, first column using row operations. Then use multiple of rows 1 and row operation, change all the numbers in that first column to a 0. Then try to change what's in the second row, second column to a 1, and then use multiples of that 1 to change all the numbers below it to zeros, and keep repeating as needed.